Right, here we go. Some paper 2 revision for you, starting with, we're going to pile through the first 2 pages as quickly as we can because this is kind of intermediate stuff. I don't know about the setup. I got you, let's see how it goes, and we'll try and keep it less dry as the last video, which a lot of you were using to help as a sleep remedy. Yeah, I don't think this will be much better, but hey, we'll get through. Right, so the volume of a cylinder, right? So the volume of a cylinder, we've got enough to learn this. Let's like draw. The volume of a cylinder is equal to a pi r squared, which is the circle at the top of the cylinder, and you can either write h, just tag it onto the end, or times h times the height. So in our question, we have got pi times a radius of 4.5 squared times a height of 8, whatever that is, right? And the answer to that will be in centimetres cubed. I'm going to try and save time here. I've got a calculator, but by the time I stop and do that, will take forever. And then part B, calculate the density of the cylinder. And the density of the cylinder is equal to mass divided by volume. We're told the mass in part B is 532, okay? And whatever answer you've got there can go in here as the volume to get your density. So the mass would be in grams, and the volume is in centimetres cubed. So the units for density are grams per centimetre cubed. Okay, that's that one. Number 2, trial and improvement. I'm looking for you to put what you're trying first. So try 2.5, okay? Trying that because it's between 2 and 3. So I always try in the middle. Then the way I substitute in, because I want x cubed, I would write 2.5 cubed, right? Plus 5x. Now you can write 5 times 2.5, but another way to do that is just to substitute the x value in a bracket there, take away 30, work it out. I can't remember what it was. I know it was negative, and you'd write at the end, well, actually, that is too small. Again, you can do the calculations yourself. So then, if that's too small, we try bigger, and when you work that out, it becomes too big. Again, you do the calculation. So what we know is that 2.5 is too small and 2.6 is too big. So the answer is between these two values. Once we get the values it's between, we check the middle. And the middle is 2.55. Okay, again, we put 2.55 in, and it turns out that 2.55 is also too small. Therefore, the answer is bigger than 2.55. So to 1 decimal place, the answer is 2.6. Okay. Yeah, okay, keep doing like this. Number 3. So we've got a rectangle, and we're told the length is 3x plus 1, and the width is x minus 5. I know they're in brackets on there, all right, and that's okay. And if we were working out the area of this, we'd leave them in brackets because we'd be multiplying the brackets together. But because it's the perimeter, we just got to add everything. So we don't need them to be in brackets. Start with the x's, 3x, add another x is 4x, another 3x on the bottom is 7x, and another x on the side is 8x. And then number-wise, we got a plus 1 on top and bottom, so plus 2 together, and a minus 5 on left and right, so minus 10, and plus 2 minus 10 is minus 8. So the perimeter of that rectangle is 8 times x, whatever x is, take away 8. So 8, we don't know the value of x, but whatever x is, we would substitute it in there to work at the perimeter. So based on that, why can x not be less than 2? Well, the reason I guess is, if it's 8 times 2 take away 8, if x were 2, 8 times 2 take away 8, then the perimeter would be 8 centimeters, which works. But if we go any lower than 2, like 1, right, then the perimeter would be 0 centimeters. Or if x was 0, I guess the perimeter would be minus 8 centimeters. So anything lower than 2 would suggest the perimeter is either 0 or negative, which it can't be. So we just need to word that saying an x value lower than 2 would give a negative perimeter, and perimeters can't be negative. Okay? Number 4, which is your Pythagoras. Okay? we are trying to find a small side. So here's your hypotenuse, right? To know it's the hypotenuse, the right angle basically points at the big side. Yeah, so we're trying to find one of the smaller sides here. We know the hypotenuse is 12. We know one of the smaller sides is 6. To find the other small side, okay, is just, we would square what we know, right? And to find a small side, it's square, square, subtract, square root. Okay, I would do that bit first. 144 take away 36, that's 108. And then you're going to need to square root the 108, which I will do really quickly if you bear with me, which is 10.4 to 1 decimal place, which is kind of a suitable degree of accuracy. So that's 10.4. But the question says, what's the area of the triangle? So we were working this out so that we now have the base and the height. And now the hypotenuse is no good to us. So base times height divided by 2 equals whatever, centimetres squared. And I'm not going to do that bit, right? The circle here, right, is the area of the circle is pi times the radius squared, right? Pi times the radius squared, and the radius of that circle is 6 because it has a diameter of 12. And again, I'm not going to work that out. You can do that. Okay, trig. Try and get a new page on you in a minute. Okay, trigonometry. Okay, let's sketch what I've got, which you can kind of see there, which is 34. Is the H or 17.9? I can basically make that out there. And I'm trying to find the length of FG, which is this side here from F up here down to G here, okay? So this side is the opposite, because it is opposite the angle. This side is the hypotenuse, because it's being pointed at by the right angle, and the other side is the adjacent. If we use SOHCAHTOA, right? We know the angle is 34, so cross out SCT. We know the hypotenuse is 17.9, get rid of H. We know that the opposite is the one that we want to find, so get rid of O. So I don't cross out A there or there because I don't know the adjacent and I don't want to know it. It's nothing to do with the question here. So the important one is so. I again do this. SOH, all right, with a little times in there and a little thing there. God, it's not the best pen. It won't grade for paper one. You're not better now. And we're trying to find the opposite. That's the important side. So the opposite is equal to S times H. S stands for sin. And in the bracket, it's the sin of the angle. So sin 34 times H stands for hypotenuse, which is 17.9. And I'm really sorry, again, I'm not giving answers. I'm just giving methods here. So if you want to go and put that on your calculator, you go ahead. And I would give 1 decimal place in questions like this. I think that's a suitable degree of accuracy. Okay, on to the second page, number 6, upper and lower bounds. So we're told that both our values here are to the nearest 0.1. So we have an upper bound for A of 12.6 add 0.05, so 12.65, and we have a lower bound of 12.55, and then for B, we have an upper bound of 8.35 and a lower bound of 8.25. So kind of these are what these are, upper and lower bounds, are the maximum and minimum the number can be so that it would round to 12.6 or 8.3, right? So what we're going to do here is 3 calculations. We want the greatest value of all these calculations. So A plus B, if I want the biggest value of A plus B, then I'd want the upper bound of A and the upper bound of B, okay? A times B, same thing. I would want the upper bound of A times the upper bound of B. But the one we've got to be very careful of is take away a difference sum. If I want the greatest answer to this take away sum, I need the upper bound of A, which is 12.65, but take away the lower bound of B. Take away as little as possible from it so that the answer stays as big as it can. So I'm going to take away 8.25. So I'm doing that number, take away that number, to get the biggest possible answer to this takeaway sum, which is whatever that is, 4 point, making it up 4, hopefully. Yeah, okay? Right. Question 7, if you can read it there, reverse percentages. I'm just going to do 7a, right? So a number, here's the number, ridiculous, isn't it? Right, the number, the full amount has increased by 30%. I've increased the number by 30%. So I now know 130% of the value of that number. The full amount plus the extra 30 that has been increased, it's increased by. And after the 30% increase, it's worth 91. The idea is we've got to find what it was before the 30% increase. So we're going to do it. We're going to find what 10% would have been by dividing by 13, okay, which is 7. 91 divided by 13 is 7. And then to get the original amount, the 100%, I'm going to times that by 10. And 7 times 10 is 70. And a quick check, right, quick check. 10% of 70 is 7, right? So 30% of 70 is 21. And if you add the 21 onto the 70, you go back to the, the answer that we had here, 91. You go back to the original, the new answer, sorry, 91. Okay, so you can always do that little check at the end. You could work out the percent that you added on of the answer and check it goes back to what you were given in the question. Anyway, tree diagrams, right? You can barely see that tree diagram here. So let me give you a little bit more kind of zoomed in, right? So what we've got is 0.65 there, so we can fill in 0.35 there. And we've got 0.2 there, maybe written as a fraction, right? And then if it's written as a decimal, you can write 0.8. If it was written as a fraction, you can write 4/5. All right, whatever they've given, then copy it down here. I'll use the fractions. I'll use a fifth and 4/5. Okay. The first event is working Monday to Friday, and we've got probably a yes and a no. All right, and then the second event is working Saturday and Sunday, and we've got a yes and a no. Yes, no. Right. So what is the probability that Caris will work all week, Monday to Friday and Saturday and Sunday? So she'll work Monday to Friday and she'll work the weekend. Okay, so part B, 0.65 times, right? I'm assuming this was given as a fraction, so we'll use the fraction 1/5. That can go straight into your calculator. And the calculator probably will give you an answer as a fraction. Absolutely, that's fine. Write the fraction. Or if not, press that FD button and write it as a decimal. If you'd rather, it's 0.13. Simultaneous equations. What we got? 5x plus, it's taking longer because I'm going to write the darn things out, is minus 6. 8x with this horrible pen. Plus 4y equals minus 12. Start with these. Make these the same for me. Get yourself a mark making those the same. Times 4 times 3. Okay, so 20x plus 12y equals minus 24. So they've all been times by 4. And then 24x plus 12y equals minus 36. Hurrah. And once you've got the y's to be the same, we then look at the signs before the y's, and these are the same signs, so we're going to subtract. Now, I always would find which equation has got the bigger numbers in. The bigger numbers are on the bottom equation, so I'm going to do the bottom, take away the top. So 24x, take away 20x is 4x. Equals, the y's are eliminated, that's the whole point. And then the bit that can go wrong here is minus 36, take away minus 24. So we actually, even though we are same signs, subtract, because we're subtracting a negative, we're actually going to be adding the 24 onto the 36 to get minus 12. So x is minus 3, minus 12 divided by 4. Okay, take the original equation here, take the original, or one of the original two. Right, and substitute in x equals minus 3. I'm shortcutting here. So 5x would be 5 lots of this, which is minus 15, plus 3y equals minus 6. The minus 15 can go over as plus 15. So minus 6 plus 15 is 9. So y equals 9 divided by 3. And that's actually positive 3. Hurrah! Go to this page here. Yeah. Right, question 10. Expanding a few brackets, 3d minus 5t, and in the second one, 3d plus 2t. It's a little bit weird, but it's alright. Foil or smiley face or whatever you want. Let's always start with that one. 9d squared. That's a bit weirder. Minus times a plus, first one means that's minus. 5 3s are 15. And different letters, t times d. So I'll just write td. Then we'll take a look at these outers, right? Or the mouth of the smiley face. Both positive this time, 3d and plus 2t. So positive 6 dt. Now, weird that when I've done td here, dt, they are actually the same term. They're td terms or dt terms, right? But that's okay. And then the final one, minus times a plus is minus. 5 times 2 is 10. And t times t is t squared. Now, even though I've written them in a different order, these two are the same type of term and can be collected together, simplified. Minus 15 plus 6 is minus 9, and I like to write them in alphabetical order. I think that's probably a nice way to do it. But the other two terms there aren't going to simplify. We'll just keep going and think, come on, we've got this. Right, we're into the higher tier malarkey. Okay, so question 11. Simplify t plus 6 to the power 6 times t plus 6 to the power 5. All we have to spot here, okay, it would be a 1 marker, don't overthink it, is it's a bracket, and there's 6 of those brackets multiplied, t plus 6 times t plus 6 times t plus 6 of them, times another 5 of them. So because it's the same thing, the same bracket, and we're multiplying them, all we're doing is using the rules of indices that we're going to add the indices. So that is it for A. And in B, we're using a division, so we're going to subtract the indices. But start with the numbers. 18 divided by 3 is 6. X, and I think, although my eyesight isn't great, that the top indice is 7, and we're taking away minus 2. So we're actually 6x to the power 7 plus 2, so 9. Question 11, done. The surface area means the area that the shape, on the outside of the shape is covered by, sort of thing. If that makes any sense. So the surface area of a sphere, just write SA, sphere, right, is equal to, you use the formula sheet for this, it's equal to 4 pi r squared. Strange, it's like 4 circles, right? So the sphere is basically covered by 4 circles. Don't ask me to prove why. And in part A, we're told that the radius of our sphere is 14, so all we would need to do is 4 times pi, 3.14, times 14 squared. Simple, okay? And then this, you can work that out again. It's not what I'm going to do. The surface area of a cone, right? You will notice when you look at the formula sheet for this, though, right, that the formula only does the curve of the cone. So if you ever think about a cone, what you're working out is the surface area of this bit, right? The curve of the cone. You're not working out including the area of the bottom, which is a circle. Now, in a lot of questions, you might not need the bottom because the cone might be stuck onto something else, right? So you only need the curved bit, right? So we'll just go with the curved bit, but just pointing it out that the formula is only working out the area of the curved bit. If you wanted the underneath as well, you'd have to add another circle on, I guess, right? So we're told that the diagonal length, which is this, is 12, and we're told that the radius is 14. If you have a look at the question there. All right. So the surface area is pi. You can get this from the formula sheet L, so that's even easier. So it's pi times the radius times the diagonal length of the cone, okay? And put that in and you'll get that. All right, fab. So think about a sphere, think about a cone, and yeah, there we go. Right. One of my favourites. Now we're going on to questions that are just going to take an age to go through. So this time, solve this quadratic 7x squared minus 4x minus 17 equals 0, but not by factorising like you would in paper 1. In paper 1, you'd factorise this, you'd be looking to put it into brackets, either this bracket or this, but that sort of stuff. You're all good at that, right? We're going to use the quadratic formula. Again, these are a couple of questions in a row here, surface area being one and this one, where you're going to have to go to the front and you're going to need to copy down what the quadratic formula is, okay? And this question might take me a little while to go through, hopefully not. Copy it. That's just me copying from the formula sheet at the front, okay? But we need to substitute some numbers in here. We're going to need an A value, a B value, and a C value. A is the number before x squared, so in this formula it's 7. B is the number before x, so in this case it's minus 4. And C is the number that is loose at the end without any x's attached, which is minus 17. Okay, so we will write minus b, but b is minus 4, right? I like when I'm substituting to put things in brackets. Right? Plus or minus the square root of b squared, but b is minus 4. Put it in brackets and then show we have to square that bracket. Minus 4, a is 7, c is minus 17. Divided by 2a, 2a. Now notice every time I've put a, b or c into that, I've put it in brackets. It's the nicer way to put it into the calculator and it almost guarantees getting it right. Okay? Now, at that point, you're going to run this calculation twice in your calculator. You're going to put it into your calculator twice, right? You're going to put it once into your calculator with minus 4 plus all that nonsense divided by all that nonsense, okay, 14, 2 sevens, right? And then that will give you one answer, or you're then going to do minus 4 minus all that and get a different answer, okay? So basically your two answers here, like when you're factorising, you'd have an either or, either this or this. Your two answers here are coming from once plugging your numbers in, but adding the square root, and once taken away, right? I should have given you the answers here, so check you put them in the calculator right. But give it a go, At question 14, I've pre-drawn this here, right? So basically, length scale factors, area scale factors, and volume scale factors. Generally, in this question, we're going to be working out a length scale factor. So it'll say, right, on my small shape, my original shape, the length is this. On my bigger shape, the same length is now this, right? So if we take a look at 14, you've got an original shape, which is smaller, and an enlarged shape. They are similar shapes. So this is a similar shape question. We are told that the perimeter of the original shape is 126. That's the perimeter. Perimeter there, and the perimeter of the larger shape is 315. Okay, these are both in centimeters. These are both lengths. We're then in the second paragraph told that the area of the enlarged shape is 937.5 centimeters squared, and we want to know that. Okay, so we know lengths. We know a length on the first shape. We know the length being the perimeter, and we know a length on the bigger shape. So our length scale factor is 315 over 126, which is 2.5. But this question is about area, so we're going to need an area scale factor, which is 2.5. And if you look at my picture here, to go from length scale factor to area scale factor here, we've got to square that. Use your calculator, that's 6.25, I believe. Just check that out for me. And because we are going from the bigger shape to the area of the smaller shape, we need to divide that by 6.25. So the question mark, the missing area, I believe is 150. Again, I haven't got my calculator there. Got a funny feeling it is though. Okay, question 15, we're getting there. Right. Okay, something new. Probably the only brand new thing in here. This is a new circle theorem. It's a really weird circle theorem as well. And the circle theorem is this. If you draw a tangent to the circle, which is a line which just touches the circle somewhere like that, okay? And from that tangent coming this way, you kind of go back on yourself this way, okay? Then from this line here, so from this dot and this dot, if you connect them to make a triangle on this side of the circle, that angle there is the same as that angle there. Conversely, guys, if I come in from this way along a tangent and meet there and go backwards this way, so my dot is there, and I make a triangle from there up here, then this angle here, which I'll colour in to show the difference, is the same as this angle here, okay? So, if you look at the picture, that one is 67, so x is 67, right? And on the picture, this one is 64, so this one is 64, so y is 64, right? So that's the circle theorem. It's not what you describe, it's called, right, and we'll talk about this again when we do circle theorems more, but this one is called the alternate segment theorem. Okay, now there is a part B, calculate the area of the triangle, but we're into the A and A star stuff here. So this isn't base times height divided by 2 area. Okay, this is the other area formula, which again is in the formula sheet, which is half AB sine C. Okay, if you look at the triangle where we're at, okay, this is 17. If you look at the picture on the left hand side, this is 12. We now know this angle here is 67, and we know that this angle here is 64, and we could work out the other angle if we wanted to, because the 3 angles would add up to 180, but if I'm going to label this, okay, let me call this side little a, and this side little b, okay, so this side would be little c, making this angle here capital C. So into my calculator, it's half a B sine capital C. So you're basically looking for kind of SAS, you would call it, side, angle, side, so 2 sides and the angle between it. So here, because it's the 17 and the 12, I know the angle that's important to me is the angle between the 17 and the 12, which is the 67. I don't need the 64. That, by the way, that's 17, not, looks like pi, doesn't it? So that goes into your calculator, and again, your answer will come out there. Right, you can work out that answer is what I mean. Question 16. Okay, this isn't one marker, but this is the other one thing, again, you may or may not have had mentioned to you, but we'll talk about it again when we do surds. Surds are square roots that don't have answers. That is a surd, that is not, because it's 4. Right? Surds are irrational. All that means is if you actually put them into your calculator and press equals, you'll get a decimal number that goes on forever. It's an infinitely long decimal number. Okay? Whereas if you put square root of 16 into your calculator, you'll get a 4, okay, which is a whole number, which are rational. There is only one other number that we know that is irrational. There is only one other number we know that goes on forever, and that's pi, which is also irrational. Okay, so the irrational numbers are pi and surds are square roots that don't have an answer. So in our question 16, the first one is the square root of 49. That is 7. That is rational. The next one is the square root of 15, which we've already said is irrational. The third one is pi. That is irrational. Okay? Question 17. Factorize these. Now, these are a bit weird, I thought. Start with this guy. Okay. Right. This is not a quadratic. So, to factorize this, we're going to go into a single bracket. Right? Now, what we'll do is the biggest number that can come out of 6 and 21 is 3. We can take a h out because there's a h in both terms, and we can take an m out because there's an m in both terms. Okay, 3 times what makes 6? That's 2. The first term is h squared, so we're going to need another h there to make it h squared, but we don't need another m. And we'll take away from that 3 times 7, okay, and we're going to need another m to create the m squared. Right, so that's a single bracket factorising. Part B, you might have to think back here now, okay? You'll look at that and think, well, it's not a quadratic, so we're not, trying to get double brackets and using that, but also there's not a letter or number that I can take out from both, so this is that unusual case called the difference of two squares. Difference of two squares. Something squared, take away something squared. So the first thing that's being squared is h, and the second thing is t. Okay. Now, if ever you get that, there's a bit of a shortcut here. You add the things being squared in the first bracket and take them away in the second bracket. Okay. Now, as you can read about 18, 18 is a 1 marker, but 18 would take me probably an hour or a full lesson to teach you. I think we need to sacrifice. You can have a little read about what I've said, and you can go away and look at it yourself if you want, but it's not something I'm going to talk about here. I'm going to move on to 19, conditional probability. Okay, and I'm going to take 3 letters from these letters. Oh, Dad, top. I don't know. Right, I'm going to take 3 letters from there without replacing them. And I want the probability that the letters are the same. Okay. The only letters that I've got that are enough of them to take 3 of them are either O's or D's. So start with O, O, O. The first O, 1, 2, there are 3 out of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. If I take an O, there are now only 2 O's left out of 10. And if I take a second O, there's now only 1 O left out of 9. Oh, here we go. Test me without my calculator now. 110 to 990. Okay. Then we repeat and we work out D, 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 this combination. But we start with 4 D's in there. So it starts with 4 out of 11, goes down to 3 out of 10, and down to 2 out of 9, which is 24 over 990. And then I need to add my combinations together. So my combined total is 30 out of 990. Okay, there are only 2 A's, so we couldn't get 3 of those. There's only 1 T and 1 P, so we couldn't get 3 of those. So they are the only combinations that are suitable here. The end is in sight. Question 20. Make P the subject of the formula. Right, well, we said we've got to get rid of fractions, there aren't any. We've got to get rid of square roots, there aren't any. Then the next thing we said in class, we've got to get rid of brackets. So let's expand the brackets. 4p squared plus 4f plus 8g minus gp squared equals h. Collect subject terms on the left. Good news. That contains the subject p, and that contains the subject p, and they're already on the left. But these other things that are not on the left need to go over there and will become negatives. Minus 4f minus 8g. Next thing, factorise to take the p's outside the bracket, but because there's p squared, not p in both, we'll actually have to take p squared outside the brackets. Okay, p squared, the opposite of times in this bracket. If I take that over, I divide by that bracket. I'm going to jump a bit of a step here now to save me writing this again. And then because I want p equals, right, because it's p squared equals at the moment, the next line, we take the squared over and we square root the whole shebang. So it's a fair bit of work. So we're expanding brackets, collecting terms on the right side, factorising, square rooting, lots to do. And finally, right, now we will talk about this in lesson tomorrow. It'll be, but by the time you watch this video, hopefully we've gone over this, right? However, right, this is our cosine rule. I believe we might, no, it is cosine rule, but dear me, this is tough. This is tough. Okay, right, part A says calculate the value of x. So let's just get bits done that I think we're okay with. So if this is 8, this is 6, this is 36, and this is what we want to begin with to work out, okay? All right, it's a general drawing, but go with it. Right, the cosine rule, copy from the front, is a squared equals b squared plus c squared minus 2bc cos capital A. In this case, it's the same three things that we need to work out the area. This becomes A, because that's the side we want. These two sides become B and C, and the angle opposite little a is capital A, which is 36. So a squared equals, and we just got to put these numbers in, guys, 6 squared plus 8 squared minus 2, 6, 8 cos capital A, which is 36, okay? Work that out. Again, I'm not going to go into it, and then square root it, because that's a squared equals, to find out what a is, all right? And in this case, what x is, okay? So that would be the first bit, a little cosine rule to find that, all right? We then, and I'm going to make this a bit simpler for the benefit of this, okay? I'm going to pretend that this angle is given to you, because I think this is a little bit too hard. But I will talk about it if it wasn't out in class, right? So we now know that this is, okay, we now know what this is, what this x is. Now, I haven't gone to the length of working this out, and I'm really sorry, my calculator's decided to pack in, so I'm going to make up an answer that is probably not right. So do listen to that, okay? I'm going to pretend that the answer to this is 7. So we've just worked out that x is 7, probably isn't. I'm also going to pretend that theta here is actually given to you to make this a little bit easier, and say it's 41. What we've got, guys, is this is a sector of this circle, okay? So the area of the sector is equal to pi times the radius squared, and we've just worked out the radius is 7. X is 7, and that is the radius. Okay, that will tell me the area of the whole circle, but if I just want this little pizza slice, I want the fraction 41 out of 360. So that's the area of that little sector. So pi r squared times 41, because that's the angle there, over 360. Now, you can see I've missed out actually working out theta, because I've got a feeling that the paper gives you theta, right? And it'll just save me a little bit of time of going over it, but it is something I will mention in class, how we would find theta using the cosine rule. But again, that can be done in lesson. Now we've got enough there to get you through this paper. Another dry video, I'm really sorry, okay, because I've been doing it quite late and rushing through it, but hopefully it'll help a little bit, and yeah, see you in school tomorrow.